The purpose of this video presentation is to outline the construction of the high-performance computing facility chiller plant expansion at the University of Texas Pickle Research Campus. This video was created for the Building Information Modeling Systems class, Construction Science 461, offered by the Department of Construction Science at Texas A&M University. Project Team. First, let's take a minute to introduce the project team and owner. The owner is the University of Texas at Austin. The general contractor for the project was DPR Construction, based out of Austin, Texas. The architect for the project was Atkins Architecture. The MEP engineer for the project was HMG and Associates. The structural engineer for the project was Datum Goer. The civil engineer for the project was Gert Einen. The fire protection for the project was provided by Rolf Jensen and Associates. Job location. The physical address for the project was 10,100 Burnett Road, Austin, Texas. Now, the site layout. The yellow shown will be the physical location of the central utility plant. Initially, the site will be accessed through the site access road as shown in red. The dark red in the top left shows the ROC expansion area. This project will be executed in conjunction with the central utility plant, but is outside the scope of this presentation. The orange shows the laydown area for the site. The green shows the locations of the job trailers. The two portions of the project will be connected by a duct bank underneath the parking lot. The red outline around the parking lot represents areas to be demolished and replaced. Now for the specifics of the central utility plant expansion. The central utility plant will house the chilled water plant that is to be constructed in conjunction with the adjoining research office complex, or ROC, which will house the fifth fastest supercomputer in the world. The purpose of the expanded chilled water capacity is to allow for adequate cooling of these high-performance computers that are to be housed in the ROC. The computer will require as much as 2,500 tons of cooling. The role of the $56 million central utility plant is to provide this cooling. The project includes a 1.2 million gallon storage tank. This tank will provide the cooling to the facility to increase efficiency, thereby lowering energy costs by allowing mechanical equipment to run at night when energy is cheaper than during peak hours. The project delivery method was construction manager at risk. Substructural schedule. Now let's take a look at the construction sequence of the project, beginning with the substructure. The first step in the construction process is to drill and place the 24-inch piers. This will be done starting with the piers that are located on column line 21, followed by column line 22 piers, and so on. The piers will be filled with concrete and steel the day they are placed in order to avoid having open holes on site for safety reasons. The depth of the piers will vary depending on when the soil reaches a specific bearing capacity. The piers for the transformer yard and chiller tower will be placed following the main structure's piers. Next, the underground MEP will be placed. Electrical and mechanical trades will have to work in close confines during this portion of the project. Next, interior grade beams can be placed, followed by exterior grade beams. After grade beams for the main structure are complete, the transformer yard beams can be placed. Next, columns for the chiller towers will be formed and placed prior to the grade beams for the chiller tower being placed to allow access. The grade beams for the chiller tower can now be placed, as well as the structural steel for the chiller tower. Now the 6-inch slab on grade can be placed for the main structure. This will be done in one pour. Following this, the chiller tower slab will be placed. The substructural portion of the project is now complete. Superstructure schedule. The first step of the superstructure's construction to begin is building the CMU walls. The first portion of the walls to be constructed will be the interior wall that will separate the electrical room from the mechanical room. This will be followed by building the northern and southern walls. These two are critical because the steel joists will grout into these walls. The east and west walls, now under construction, are not critical to steel erection. During the construction of the CMU walls, the chiller tower has begun. The construction of the chiller tower will continue until the end of the schedule. Now the 6-inch steel columns will begin to be erected. These columns will support the stringers and the joists, which will support the roof deck and membrane. Following the completion of the columns, the 2 rows of stringers can be erected. Following the erection of the stringers, the steel joists can be constructed. The roof deck and membrane can now be installed. The brick veneer surrounding the CMU can be installed around the outside of the main structure. Following the completion of the roof, which is hidden from view, the mechanical, plumbing, and electrical trades can begin to complete work inside of the equipment and electrical rooms. Mechanical room. Now let's take a look inside the equipment room. The pumps for the chiller tower are visible, as well as the overhanging pipe from the mechanical systems. Clash detection. Finally, the implementation of building information modeling on this project will allow detailed clash detection between different scopes of work. These are examples of issues that have been detected prior to construction beginning. Correcting these issues before they arise in the field will allow a shorter schedule and a lower cost to the owner. Thank you for your time in viewing this presentation. Special thanks to DPR Construction for assistance with this class project.